Hi, welcome to week one, which is all about one-dimensional motion, position, velocity, acceleration. In this first module, we're going to be talking about these topics in detail. These are the fundamental knowledge that you need to have for the rest of the course. So it's important to really understand these basic elements. First of all, let's just talk about the idea of position and measurement. When I say position, I'm really referring to the actual physical location of something, typically in terms of unit of measurement. For example, I could say that I'm standing right here, or I could say that I am standing in a particular location in a particular city, or give a geographical coordinates in latitude and longitude. Understanding where something is initially and where something is later on is key to understanding motion. For example, here I am. Now I move off to the side. I have moved. I know that I had a position initially. I know I had a final position. If I know the difference in time, that tells me, at least as an average, how fast I moved in that period of time when I was moving. So understanding our position, we need to have a measurement. We call this our initial position. We also need to know our final position. And if we have these two elements, we know quite a lot actually about how we've moved. We know where we started, we know where we finished up. That gives us a lot of information that we need to know to understand the motion itself. Speed. Speed and velocity. They mean the same thing? Not quite. When I say speed, I'm really referring to how fast I moved. So I just moved. How fast was that? That is a speed. When I say velocity, I mean a speed and a direction. So when I say I have a speed of 1 meter per second, or I say I have a velocity of 1 meter per second due north, that's the difference. A velocity is what we refer to as a vector quantity. It has a magnitude and a direction. It points in a particular direction, and that allows us to know, if we only know the initial position and the velocity, where the final position will be. If we knew the initial position and a speed, we would know how far away from that initial position we would be at the end, but we wouldn't know exactly where that final position was. For example, let's say here is my initial position, and I have a speed. Let's represent it by this vector. Now, if I only know the speed, that vector could be in any particular direction. So I could end up anywhere on this particular circle surrounding that point. If, however, I know specifically that this is my actual velocity, then if I start out here, I will end up here after a certain period of time. Acceleration. So velocity is a change in position over a period of time. An acceleration is a change in velocity over a period of time. When I say acceleration, I'm once again referring to a vector quantity. You might be used to the idea of acceleration as always meaning speeding up, when in fact an acceleration can, because it is a vector, have a direction. So if I am in my car and I am moving forward faster, I'm accelerating. If I'm in my car and I'm moving forward more slowly, I'm also accelerating. People commonly refer to that as a deceleration, but really it's more appropriate to refer to it as a negative acceleration. My speed starts out high, it ends up low. It has changed, it has gone a little bit negative, and so I say that I have a negative acceleration. Position gets us to velocity or speed, and a velocity or speed change in unit of time gets us an acceleration. This essentially is everything you need to know for this particular week, and you'll see a number of problems talking about evaluating position, evaluating a velocity, and evaluating an acceleration. The discussion board post this week is to take a look at the I'll Go Do videos you see below, and look at how they apply to a Rube Goldberg machine, and additionally what it means to understand the velocity and acceleration that you see. What I would like you to do is, in the video, choose a particular section and estimate from that video what you think the speed of an object is. Then I want you to take another step further and figure out how accurate you think that measurement is. For example, If I'm referring to my height, I could say that I am 6 foot 1 inch tall, or I could say that I am 2 meters tall. If I say that I have a value of 6 feet 1 inch, that is a unit of measurement. And I'm assuming that by saying this, you're probably gathering that I really mean I'm somewhere around 6 foot 1, maybe up to 6 foot 2, maybe down to 6 foot, but somewhere within that range. That's my accuracy. If I say that I'm approximately 2 meters, what do I mean about how accurate is that? Does that mean I'm as much as 3 meters or as low as 1 meter? An estimate of accuracy tells us how confident we are in fact, that we have a particular measurement of value. If I say that I'm 2.0 meters tall, that is making a much more accurate declaration about my actual apparent height. How is this important? Because when you try to make a measurement in physics, people often will try to record a value to officially an infinite number of decimal points. You'll get an answer 43.67235 meters per second. That's what you get out of your calculator, and you write that down. What you're really saying here is that you know this speed incredibly accurately, when in fact, you may really only be able to say that you know it's about 43 plus or minus 1 meter per second. So think about this concept of accuracy in terms of the videos that you're looking at. Estimate the velocity on that video, and then estimate how accurate you think you can determine that velocity based on what you see.